Hi, and welcome to part 1 of this Python Deep Dive lecture series. I'm really glad that you're joining me in this journey to understanding Python at a much deeper and more fundamental level. So what is this course about? Well, it's about the Python language and the built-in types and the standard library. This is not about third-party libraries. There are tons of great third-party libraries. But I think before we start diving into third-party libraries as Python developers, we need to really understand what's already built in. Python is called a batteries included type of language, and it really goes beyond the language because it's the standard library. So there's a ton of functionality built into Python, and we should really understand and know what that functionality is. So this is hopefully a course that's going to help you become an expert Python developer. It took me a long time to really truly understand Python, and I'm still learning things every day. And I hope that this course will make that journey for you a little bit easier. It's also going to be about idiomatic Python. So what do I mean by idiomatic Python? Well, the thing that you really should look at, it's called the Zen of Python. If you haven't seen this before, it was written by Tim Peters. And if you're in a Python shell, you can just type import this. And when you import this, and you can also get it from PEP20, which are PEPs, by the way, are very important documents that talk about the functionality of Python as it gets implemented. Sometimes PEPs get implemented into the language, sometimes they're not. And even the ones that aren't implemented are really useful to read. So I strongly suggest that you start looking at the PEP documents, and we'll talk more about PEPs later on. So here's the Zen of Python. I'm not going to spend any time discussing that. I just wanted to mention it so that you keep this at the back of your mind and keep going back to this, and think about it. Because that, I think, helps people, that helps us write good Pythonic code. So beautiful is better than ugly. Explicit is better than implicit. Simple is better than complex. Keep it simple, right? But complex is better than complicated. Things can be complex, but they don't have to be complicated. Flat is better than nested. Sparse is better than dense. Readability counts, and you'll hear me mention that again and again, that throughout this course, that readability is really important. Not to the Python compiler and interpreter. It couldn't care less if the code is readable and dense and nested and and complicated. It doesn't care. Why do we care about it? Because human beings are writing this code. Human beings are reading this code. We need to be able to understand as human beings what that code does. Because that's the only way that, first of all, we're able to write it, and the only way that we're able to debug it and understand what something does. Special cases aren't special enough to break the rules. But practicality beats purity. Sometimes you do break the rules. Sometimes, we have conventions, and I'll talk about conventions like naming conventions. Sometimes you break those conventions. It's okay to do that. But it should be, an explicit thought process on your end about, I'm going to break this rule, I'm going to break this convention for some specific reason. Errors should never pass silently unless explicitly silenced. And we'll get to that in a later series, actually, when we look at error handling and error trapping. In the face of ambiguity, refuse the temptation to guess. There should be one, and preferably only one, obvious way to do it. There's always more than one way to do something, but there should really only be one obvious way to do it. And it's this, goes back to this Pythonic or idiomatic way of programming. Although that way may not be obvious at first unless you're Dutch. If you're wondering what that means, you need to look at who, created Python. It was Guido van Rossum, who is Dutch. So that's obviously a reference to him. Now is better than never. But never is often better than right now. Don't rush into things. Think about it. If the implementation is hard to explain, it's a bad idea. If the implementation is easy to explain, it may be a good idea. And namespaces are one honking great idea. Let's do more of those. And we'll talk about namespaces in this part of the series in the section on modules and packages. All right, so what's the course going to cover? Well, first we'll do a quick refresher. You should already know Python coming in, but only at a beginner level. You don't have to know a whole lot, but you should be aware of Python's type hierarchy. At least some of the basic data types like ints and floats and tuples and lists and dictionaries, kind of the simple stuff, anything you'd get in an introductory Python course. We'll talk about variables. We'll talk about conditionals, if, else, elif. We'll talk about functions using the def statement. We'll talk about loops, the for loop and the while loop. Then we'll talk about break and continue, which is how we can break and continue out of loops, but in the context of try statements. And then we'll cover classes as well. So this is really just a quick refresher. It's going to be very basic Python. I'm not going to get into a lot of details on this, just to make sure that we have the basics covered. The first main topic is going to be variables and memory. What are those things really? What are variables? And we'll see that they're merely just symbols, and they're symbols for memory addresses. So we'll see what that is. So we'll talk about memory. We'll talk about Python memory management. In particular, we'll talk about reference counting and garbage collection. Those two are related, but they're not exactly the same. We'll talk about mutability and immutability. What is that in reality? And in particular, we'll also focus on mutability with function arguments and shared references, because there are some caveats there. And then we'll talk about equality. What is the equality of two objects? What does it mean to try and compare two objects? Then we'll talk about Python memory optimizations. Python does some things that once you start understanding what variables are and memory and equality of objects, you may be surprised at some of the things that are happening. And that's because Python is trying to optimize memory usage and optimize, for speed. So it's trying to do some optimization. So we'll talk about those. We'll talk about interning, string interning, peephole optimizations, and we'll see what Python does. Next, we'll cover numeric types in a lot of detail. So obviously we'll talk about integers, but we'll talk about rationals as well, fractions basically. We'll talk about floats in depth. So we'll first look at the binary representations of floats. How are floats actually represented in computers? Computers really only understand zeros and ones, binary values. So we'll talk about the exactness of floats, or the lack thereof. And we'll talk about the standards, the IEEE standards for representing floats in computers, which is what Python implements. So we'll talk about rounding as well. And if you haven't spent any time with rounding in Python and many other languages, you might be surprised at what happens when you round certain numbers. Then we'll talk about equality of floats and why, in general, we don't use equality in terms of values with floats. It doesn't work. And it has to do with the exactness. And so we'll talk about something that's related to that, which is approximate equality or measures of closeness. If we can't compare floats directly through equality, how can we compare them? Then we'll talk about decimals, and that's an alternative to floats. We'll talk about the exactness and the precision that we have in decimals. And then we'll also talk about rounding in decimals too. And then finally, we'll top that off with complex numbers. We're not going to explain what complex numbers are. We're just going to basically talk about the fact that, we have complex numbers built in to Python. And then I'll also show you very quickly the CMath standard library, which is for complex numbers, like math is the standard library for floats. The last numeric type that we'll look at are the Booleans. They're actually integers. Booleans are integers, and we'll see that in the lectures. But we'll see that every object in Python has an associated truth value, and everything in Python is an object, including functions. So functions actually have truth values to them. Then we'll talk about precedence and short-circuiting with Booleans. We'll talk about the Boolean operators, the and the ors and the nots, and what they really do. Because very often we come in thinking, well, the Boolean operators and an or, they just, take, for example, two Boolean values and they return a Boolean value. Not so in Python. It actually does something else. So we'll see then those Boolean operators, how we can leverage their actual functionality in the context of the associated truth values that every object has. Then we'll also talk about the comparison operators. So we have things like identity and value equalities. What are those? What do they mean? And we'll talk about the ordering comparisons as well. And very briefly, we'll mention the membership comparison operators as well, like in and not in. But those actually will be in part 2 of the series when we look at iterables. So functions. We'll start off with higher order functions. Functions are first-class objects in Python, and so we can have what are called higher order functions, which are functions that can take in or return functions. We'll look at docstrings and annotations. We'll look at lambda expressions or lambda functions. They're just plain ordinary functions. There's nothing particularly special about them. Then we'll look at introspection in functions. How can we introspect a function to get a hold of the variables and the default values and things like that, and even the code. Then we'll dig into functional programming. So we'll look at things like map, filter, and zip. We'll also look at reducing functions, and we'll look at partial functions as well. And then we'll see how a lot of this can actually be replaced by using lambdas and other techniques that we have in Python, like, for example, comprehensions. So functions and arguments. So we'll talk about arguments in depth as well. The way that we can specify arguments to functions in Python is actually quite complex. It's very flexible. So we have positional arguments and keyword-only arguments. We'll talk about those. We'll talk about default values, and we'll talk about caveats with default values, because we have to be careful with default values. And then we'll talk about packing and unpacking of iterables in general, and then we'll talk about packing and unpacking of arguments for functions. We'll also talk about variable positional arguments. We can have a variable number of positional arguments as well as variable keyword-only arguments. Then we'll talk about scopes and then closures. Closures is very important. So we'll cover global and local scopes. We'll explain what those are. We'll look at nested scopes. And then we'll look at closures and what are closures. And that's really important. And then we'll look at nested closures as well. That's also really important. We can nest closures within closures. And that will then lead us to decorators. So we'll look at what decorators are, how we can create decorators. We'll look at how we can create nested decorators, since decorators are basically closures. And then we'll see, once we have this concept of nested closures and decorators, how we can have parameterized decorators. We'll look at how decorators can be stacked. We'll look at how we can decorate classes. And we'll look at how we can use classes to decorate functions or classes. So class decorators and decorator classes. And then we'll look at applications of decorators. So we'll look at things like memoization, single dispatch generic functions, logging, timing. Some of these are actually part of the standard library, but I will show you how we actually build those things, and we'll do it ourselves. And then we can use the ones that are built into the standard library, but at least we'll have a foundation of understanding how it works. And I'll show you different memoization techniques as well as other types of decorators. Then we'll look at tuples. Tuples very often are presented as read-only lists, and I do the same thing. When somebody asks me what's a tuple, the easy answer is it's a read-only list. And it is a read-only list. There's nothing wrong with thinking of it that way, but a tuple is really not just a read-only list. There's actually a lot more to it. It's actually a data structure, and we can use it as a read-only list, but it's really a data structure. So we'll look at that in some detail. We'll look at packing and unpacking of tuples. We'll look at something called named tuples and why we really should leverage these far more often than we do. And then we'll look at how we can augment named tuples. We'll look at named tuple manipulations, extending named tuples, not through class extensions. This is just going to be extending it, creating one named tuple from another. We'll look at also adding docstrings to named tuples. We'll look at setting default values for named tuples. We'll look at 2 different methods of doing that. And then lastly, we'll look at modules, packages, and namespaces. I think that modules, packages is probably one of the more complex parts of Python. We kind of write Python code, we write them in files, and those are modules. But what are modules really? And what happens? When do they get executed? What happens? When do they get loaded? How do they get loaded? We'll look at all that. Then we'll look at what packages are and how they relate to modules. we'll see how the various imports work. If you've worked with Python import statements before, you know that there's different variants. You can say from, this, import that, or import this, or from this, import star. There's different variants of that import statement. We'll see what each one of them does and how they relate to each other. We'll see how we can manipulate namespaces using packages. So packaging is something that allows us to split our code in different ways, and yet we can still present it in a different form to whoever's using our code. So we'll take a look at that in quite a bit of detail as well. We'll look at zip archives and some of the fun stuff we can do, and we can actually run Python applications directly from a zip file. And we can also import directly from a zip file. So we'll see how to do that. And then we'll talk about done domain as well in that context, and we'll see what done domain does. And there's actually two flavors of done domain, and we'll look at both of them. And then finally, there's the extras section. So this is really, something that's going to keep growing over time. It's kind of a miscellaneous, bag. I'll talk about important new features of Python 3.6 and later as they come out. Anything that I find interesting or important, I'll add to that. I'll talk about best practices sometimes. The do's and don'ts of certain things. I'll pick examples and show you. It's just going to be a random collection of interesting stuff. And for example, I will cover random collections. I also will give you additional resources. I have already some videos on that, on additional resources, and as I find new ones, I will keep updating that as well. And then send me your suggestions. Really, I think, anything that you want to see in here, let me know. Send me your suggestions, and I'll see if I can come up with something. All right, so I hope that you're going to enjoy this course. It's going to go into Python into quite a bit of detail. So this is not an introductory course. You should have a background in Python already. And the next two articles in this section will explain, what you should know already, what are the prerequisites for this course, and kind of what you're going to need in order to follow along with me, which is not a whole lot. You need to be able to run Python, and you should be running Python 3.6 or above. And you need to be able to either, create Python files using command line and, something like VI editor, or you can use PyCharm. I'm going to use Jupyter Notebooks quite a bit because it allows me to intersperse comments with code. So you'll find that a lot of the code that I have in this course is going to be in Jupyter Notebooks. But you don't have to use a Jupyter Notebook to follow along. You can just type it directly into a console, a Python console, or you can use, files and type your code in files and then compile it and run it from the command line. However you want to do it, that's fine. So thanks for watching, and I look forward to seeing you in the next video.